Hello and welcome to my science tutorials. In today's video, we want to look at WAEC chemistry past questions and answers, specifically the SSCE 1993 question number 1C and question number 1D for chemistry. Right, so without further delay, let's begin. So during 1993 Wassce, or as at that time SSCE 1993 question 1C and D for chemistry, we had to complete the following table. So we have the table having the name of particle, the relative mass, the charge. So we can see that the first particle we've been given over here, let me use the highlighter. We've been given a beta particle. We were not given the relative mass and we were not given the charge. For the second particle, we have no particle, but we're given the relative mass and we're not given the charge. Then we have an alpha particle with a relative mass of 4 but no charge, and then a proton without a relative mass and then without a charge. So we have to find the places under the table where we have the missing values and name of particles. Now the B aspect of that question is demanding that when air is studied in a mass spectrometer, the most intense lines obtained are for masses 28 and 32. We are to explain why it is so. What other lines do we expect to find? Right, so let's go ahead and have a look at the solution for this problem. So solution. Now for our table, first, the beta particle has a relative mass of 0. Okay, the relative mass is 0, and then the charge is -1. The charge of a beta particle is -1. Now for a particle that has a relative mass of 1, since we already have a proton which also has a relative mass of 1, then we know that this side where we have just 1 given to us will be neutron. So neutron has a relative mass of 1 and then it has a charge of 0. Now the third particle is alpha. We're given the relative mass to be 4, and then the charge on an alpha particle is +2. So +2 here is our answer. And then for a proton, it has a relative mass of 1 and then a charge of +1. Now note that for the charges, we have to include whether it is negative or positive. That is why I'm not writing just 1 here. I'm including -1. And then for +2, it's not just 2 over here. I'm making sure that I have the positive sign in front of the 2 to show that it's +2 as a charge. Alright, so let's have a look at the second aspect of this question. So they said when air is studied in a mass spectrometer, the most intense lines were obtained for the masses 28 and 32. We have to explain. Now we know that air is a mixture of gases, and out of all the gases that constitute air, nitrogen gas and oxygen gas constitute the most abundant of all the components of air. Now because they are the most abundant, it makes sense that when they were studied in a mass spectrometer, they have the masses, the relative mass of nitrogen gas, which is N2. Nitrogen has the relative mass of 14. So nitrogen gas will be 2 times 14, that will give us 28. And then for oxygen is relative mass is 16. So 16 times 2 will give us 32. So it makes sense that we are having the most intense lines at 28, which represents nitrogen gas, and then at 32, which represents oxygen gas. This is because nitrogen gas and oxygen gas are the most abundant gases in air, and hence the reason why they appear as the most intense lines at 28 and 32 respectively. Now what other lines do we expect to find? Now we have other gases that are in air. It's not just nitrogen gas and then oxygen gas. We have other gases such as carbon dioxide and then water vapor, which are also in fairly high amount. So apart from the nitrogen gas and then the oxygen gas that we are expecting to be the most abundant, other gases that we are expecting to be present and we are expecting to see their lines in the mass spectrometer are carbon dioxide. So we are expecting the carbon dioxide some lines to appear for carbon dioxide at the mass of 44, and then water vapor, some lines at 18, the relative mass of 18 for water vapor, and we're also expecting some lines for inert gases. So we are expecting lines like line at 44 for carbon dioxide, and then line at 18 for water vapor, and other lines for inert gases. So these are the other lines that we are expecting to be seen in this particular mass spectrometer that we've been given. So this is the solution to the problem 1993 SSCE question number 1C and question number 1D. This is the solution to the problem that was given to them as at that time. So thank you so much for watching. I will see you in the next video, where we'll be talking more about WAEC chemistry past questions. So thank you once again, and I will see you in the next video. Bye bye.